if you are taking my course right now, you can type .uu. Okay, so we are going to do this one. Okay, so this is comparison R and Python. In addition, I'm going to use the dictionary. I'm going to use a dictionary, and also I'm going to use search webs. Okay, so if you are not taking my course right now, and you can issue this line of our code, http .111.0n compare txt. Okay, so all lowercase source http datayy.con compare .txt. Okay, so there are three functions here. The first one called compare R _ Python. Okay, compare R with Python, and also I have a shortcut. Okay, so you type .com, and so there are three entries. For this video, I'm going to discuss the first two. Hopefully, I have another two videos. We'll cover 3, 4, and 5, 6. Okay, so go back, type .rpy, then we go back to the main menu. Okay, I'm going to use these two functions. Okay, the first one is called the search web. There are so many, I generate close to 100 data sets available, because when I compare, I have R, I have Python, and we're going to show you. Okay, type the name. So let's search. SEARCH, search web. So if you type the function name, then you can see the usage of specific function. Okay, .search web, and you can .speech. You can type enter speech. Obama 2008 speech, Reagan 1964, Trump, and the shortcut is .sw. Okay, and after use keywords and we get the ID, then .sw222 is equivalent. Then we go to specific web page. Okay, I'm going to show you. Okay, search web, speech. Okay, then we know this is 225. Okay, so this is different. Okay, 225, and we use up arrow key to record the previous command. Then we enter 225. Okay, so 225. Okay, the underlying software will go to specific location. So this is location. So equivalent to we copy and paste to a browser. Okay, and in addition, suppose let's try another one. Search web. So this is F3 monthly. Okay, from our French, 3-factor model is monthly. Okay, then we have like CSV file, and also we have FF3 monthly data. Okay, so actually, you see, we can simply copy. So we call the in file. Okay, in file equals, and we paste it here. Okay, then we can use X, get URL, load URL. Then we can use in file. Okay, then we can get then we will get this data set. Okay, and also we can also copy and paste to the spider, to the Python editor. Then we can try and retrieve our data set from Python. Okay, so let's go back to our main menu. Okay, dictionary. So dictionary and it's usually compare R with Python. For example, dot dictionary, we know the RLS, we list the variable. This is RS show variable, and corresponding Python function is dir. Okay, the shortcut for the dictionary is .dict, like .dict, read.csv. We know for the R we use read.csv, and for the Python we use pandas .read_csv. So this, and so we can use dictionary to find all the function associated with both R and Python. If you know the R code, you can search corresponding Python code, vice versa. Okay, and for example, let's show DICT. Okay, suppose we know the load, right? We load, so let's load. Okay, for the R, for the load R of Pico dataset. For the R, we can use the load to load a local one. Okay, and corresponding Pico is pandas. Oh, should be pandas.read Pico. Just type .com. Okay, so let's start. .com. So this is a comparison between R and Python, and for this video I'm going to discuss the first two. Okay, the first one is with up arrow key, then we enter 1. Okay, I'm going to make it a little bit smaller. Okay, so this is 14. Let's make it 14. Okay, so we have complete. Okay, so this is the first video to compare R with Python. Okay, the prompt. So this is our prompt. Okay, so if you look at bottom here, so this is our prompt. Okay, because for this semester I only use the spider. Okay, then you will not see this one. Okay, so actually if you launch Python like this one, okay, so I'm going to show you. So let's launch it, then you will see they are straight and larger than. That's prompt. Okay, so I use this one to compare R and Python. Okay, case sensitive, so both R and Python are case sensitive. Okay, actual space for R, it doesn't matter, however it matters for Python. Okay, so let's try it. Suppose let's use the simplest one, def. So this is we are going to have a function called a double. Okay, so we're going to return 2x. So I'm going to make it bigger. Okay, make it bigger. Okay, so this is a definition of function. So this is function name. Input x and we return 2x. Okay, if we run it on the right hand side, we will see like this is error message. Okay, so we have to, so you like do this way, this x, and I'll delete. So indentation is very important for the Python. So this is dd 2.3 and we got 4.8. So this is like a power function with your caret for the R, and we can also use to start. Okay, I can show you here like pen, caret 3, and we got 1 solid. Alternatively, we can use to start. Okay, to start, then we got 1 solid. Okay, so let's go back to Python from here. Okay, suppose we use 10 and *3. We have 1,000. However, we use 10 caret 3. Then we get a 9. Okay, so this is not a power function for the Python. Okay, so let's go back to R. Comment. Okay, for the comments, we use the show our variables. Okay, for example, we have present value equals 100, 100 R equals 10%, and equals 5. Okay, so if we want to show all the function, we can use ls, left, right, parentheses. And for the Python, we have two ways to do it. So we can use present value equals 100, R equals 10%, and equals 5. Okay, we can use dir, we can use print dir. Okay, so print dir, left, right, parentheses. Okay, then we'll see our value here. So n, pv, and r. Okay. Alternatively, we can see the variable here. So variable. Then we can see the n value is 5, pv is 100, r is 10%. Okay. And for the Python, it's more flexible of using the spider. Okay. So let's go back to R. Okay. Another, if we want to keep different command line on the same line, we use semicolon, and this is true for the Python. However, this methodology is not recommended. It's much easier to debug if we have one command line occupied one line. Okay. Okay. So this is number side is comment. If we have one short comment, for R, for Python, we use the number sign. Okay. For the second type, and for the R, we use one pair of double quotation for the multi-line comment. For the Python, we use triple double quotation marks and triple. Okay, triple here, okay. And check the data type for the type of and type. Okay, so let's look at so we type of present value. Okay, then type of present value is double. So let's go back to Python. So let's go back to Python, and here we type present value. Okay, and so actually it's integer. So let's use present value. Present value equals 100 dot. Okay, so this is present value equals 100. Present value equals 100 dot. They will have the different meaning. Okay, 100 will be integer, and this will be float. And next, I'm going to show how to write a simple function to calculate the present value of one given future cash flow. Okay, so this is Notepad. So this is present value function. Okay, so the function is keywords. Okay, input, future value, R, and N. We have 3 input. So this is output, and also is the function of our output. Okay, so I'm going to copy paste to the R. Okay, so this is if I enter $100, 1%, 10% for 1 year. So this is, I simply put $100 as the future value, 10% as R, and 1 period. Okay, then we got $90.91. Okay, so this the first input according to the order. Okay, so suppose the first one is 10%, and then we have 100 and 1 period. Then we will get a very, very small values, because this 10%, this is 0.1 refer to the future value, and this is interest rate, and this is 1 period. And this kind of input method according to the order. Okay, the first number is always future value, the second number is always discount rate or interest rate, the last value is always the number of the period. Okay, alternatively, we can enter keywords. For example, R equals 10%, and the future value equals 100, and N equals 1. You see here, we first number is 100. Now we first number is interest rate is 10%. Okay, so this is called keyword approach. Okay, and we can N equals 1, R equals 1%, future value is 100. Okay, so all these three we get equivalent value. Okay, the first method is based on the order of the inputs, because we don't have any keywords. Okay, the second method, and we specify keyword. Okay, then order does not play a role. Okay, so this is second method. Okay, so let's go back to, so this is one line. Okay, so actually we can add a curly bracket and curly bracket. Okay, so this pair indicate anything between belong to this PV underscore F function. Okay, and actually we can enter some so-called comment, and okay, so present value equals this value, and we have return. Okay, even return for most cases, okay, return is redundant. However, it's a very good programming habit to have a return. We know exactly which value we will get. Okay, and so this one usually I add objective. Okay, calculating present value of a given future value. Okay, then I'll define the future value, I'll define the present value, I'll define the interest rate. Okay, and also I can also specify formula used. Okay, so this is, and I can use future value divided by 1 plus R raised to the power of N. And also I can example number 1, example number 2, and example number 3. So usually for example number 1, I can specify the first method. Okay, the first method, we input our data according to the order. So this is, so usually I call and method 1. I can also specify, and we input the data according to the order. Okay, so this is the second method. Okay, the second method, we input with key. So sometimes I can mention here method 1, input according to the order. Okay, and so this is I called method 1. So this is method 2, and keywords. Okay, so this is ISO keyword approach. Okay, and also then you can add the example 3, example 4. Okay, so I'm going to copy and paste. So copy paste to R, and you can use source. You can use source to run it. Okay. Okay. I'm going to clean the screen. Okay. So if when I type the function name, just function name, then I have this the top part. Okay. It will show us the explanation. What is usage of this function? What are the meaning of 3 input variables? And what is formula used? And also there are several examples. Okay. With this kind of help, and we don't have explain to our future user, to my students, even in the future to myself, because after 6 months, I might totally forgot what is the meaning of each functions. I'm going to copy and paste this function to Python, just modify our code, and to look at the difference between R and Python for this simple function to calculate the present value of a given future value. Next, I'm going to copy and paste exact the R function to the Spider, to the Python editor, to convert it into a Python programs. Okay, I'm going to paste it here. Okay, I'm going to make it bigger. Okay. Okay, the corresponding keywords is DEF. So this is DEF. So this is, suppose we use the exact same function name. Okay, so this is present PV underscore. So we have 3 input. Okay, for the Python, we don't use curly bracket. So we use, okay, I'm going to use 3 and 3 here. Okay, 1, 2, 3. Okay, then we calculate future value, then we return our future value. That's it. Okay, so this is our objective. This is present value. Sorry, this is okay. So this is discount rate. So this is n. Okay, so we have example 1, we have example 2, and we can use like 1, 2, 3. Okay, 1, 2, 3. Okay, then we have more. Okay. Okay. So this is almost identical compared with the R. Okay, the difference is, the first difference is we use DFF for Python. For the R, we use function. Okay, for the R, we use a parallel curly bracket, and for the Python, we use colon and alignment. Okay, I'm going to run it. Okay. Oh, so this is, we have to use equal. Okay, equal. Okay, I'm going to run it. I think it's an alignment issue. Okay, alignment issue. Let's run it one more time. Okay. Okay, so this is present value underscore 100 and 10%, 1 period. Okay, we got the same result. Okay, so let's try, and so R equals 0.1 and future value equals 100 and equals 1. Then we have the same result. Okay, so actually it is it's quite similar in terms of input or data depend on the order, and the input, the value of input variable, the meaning of an input variable depend on its keywords. Okay, depend on its keyword. Okay, so let's look at some standard. Use search, web. So let's look at IBM monthly. So IBM monthly. So this is I'm going to show you later. Okay, so this is the IBM monthly. So let's copy. So this is in file and equals. Okay, so in file equals. Okay, so let's use xrate.csv in file. Okay, so let's head. So this is in file. So this is location of our CSV file. Rate.csv in file. Okay, I'm going to copy paste this one to Python Spider, and let's look at corresponding Python code. Okay, so this is, I'm going to make it bigger. Okay, so import pandas as PD. Okay, so in file, same thing. Okay, so data frame equals panda rate underscore CSV in file. Okay, and so we are going to run it. So there's no error message. Input data, and so let's run it. Okay. Oh, this is pandas rate underscore CSV. Okay, and instead of head df, we use df head. Okay, so we use df head, then we have same result. Okay, so it is very, very important. We should show the first several lines. Okay, so let's go back to Python. So let's look at the IBM monthly. So let's call it's fake. Okay, and suppose we have no clue. And in file. So let's run it in file. Oh, we should call it in file 2. Okay, so in file 2, and so x2 equal rate.csv in file 2. Okay, many of my students they have CSV, they input, and they don't see any error message. So let's look at x2. Okay, dim x2. You see, we have 6 rows and 1 columns. Okay, so if you look at this carefully, okay, even here mentioned CSV file, the separator is semicolon. It's not comma. Okay, so the correct input should be SEP equals semicolon. Then we look at x2. So this is a correct way to input. Okay, so let's look at spiders. Okay, for the spider, so this is x2, and with data frame 2 equals pd rate underscore CSV in file 2 sep. You see here sep equals. Okay, so this one. Okay, then we can just run in file 2. Got error message. Oh, this is equal. Okay, in file 2 we have used equal signs, and we specify semicolon, so df2 head. Okay, then we have correct input. Okay, so let's see if we don't specify this one, and the df2 head. It's quite different for this one. We have 1, 2, 3, 4, 5, 6, 7 with 7 columns. Okay, For this one, we only have one column. Suppose we use import numpy smp mp shape. So this is df2. You see, we only have one column. Okay. Suppose we use sp equals. Okay. So if we use this correctly, then we call this. Then we see 7 columns instead of 1 column. Okay. So it is very, very important, and we should print a few lines, a few records, tail and head and tail. We can apply head and tail functions. Okay. Okay, so let's look at another one. Another one is related to the search web and fake CSV. So let's look at another one. I mentioned this one for the data case, no, for the homework number 8. Okay, and again, so this is in file. So let's call this one A. So this is A. So A $web, and so let's choose first one. So this is our link. Okay, so this is data frame 3 equal read CSV. Okay, so let's call it x3. And so let's call it x3. And dim x3. Okay, it's 508.1. Okay, so let's look at x3. Okay, so x3. Then you will see if you just copy and paste this one, you copy. Oh, I called the. Yeah, suppose I just use what is called browse URL. I paste it here. Okay, I paste it here. Then you will see this is not a CSV file. This is web page. Okay, so don't fool yourself with this this .csv. Okay, and for this case, if you really found the true link, you should click raw. You see, click raw, and so this is raw data. Okay, then you copy paste this one. Okay, so let's copy and paste it. Okay, so let's call it in file 4. So let's call this one in file 4. Okay, you see the difference and this. So let's copy. Let's look at this one. So let's look at A. Okay, A is this web page. Okay, the correct one should be raw. So this is correct one. Okay, so let's look at info. So x equal read CSV in file 4 hx. Then we have correct input. Okay, we have correct input. Okay, so the bottom line is we cannot simply look at the final output with the file with something .csv. Then we assume it is dataset. We at the same time we assume it's this dataset use comma as a delimiter or as separator. Next, we are going to discuss download function. Okay, and so let's. I'm going to click this one and search web. So let's find one dataset. Say monthly. So this is from a friend monthly data. So let's download this one. Okay. So let's code in file. So this is our in file. Okay. So this is our in file, out file, and so let's use ff3 monthly rdata. Okay. So this is our in file. So this is our out file. Okay, for the R, it is download. So download file. Okay, in file, out file. Okay, then we download. Okay, so actually we have in file location, then we have out file, then download dot file. Okay, so I'm going to copy this 3 line to Python. Okay, so I'm going to delete unnecessary file. Okay, I'm going to make it bigger. So this is in file. For the Python, we have several modules. Okay, usually I use the download from, download, import, download. Okay, so why I prefer use download because it's so similar to the R. Okay, so it's easy for my students to remember. Okay, and so this is almost same. Okay, from download. So this is module, input, download. The second download is function. Okay, from download. So this is in file. So this is out file. Okay, we have extra this one. So this is out file. Then on the right hand side, we download successfully. For the R, and we have several functions. One is called read.csv, and another one called read.table. So actually, these 2 functions I claim they are all almost identical. Okay, almost identical. The only thing is, suppose we use read.table to read.csv. We have to pay attention. Okay, the first one is we have to use comma. Okay, if we use read.table to read a CSV file, we have to specify comma. Okay, I'm going to, so let's use search web. So let's use IBM monthly. Okay, let's use IBM monthly. Okay, so let's read this one, IBM monthly, and we did it already. Okay, so x equal read dot, so let's call it in file equals, so this is in file, so x read dot csv in file. Okay, so this is our benchmark. Okay, so everything is fine. So let's use x2. Okay, so let's use x2. Let's use read table. Okay, without specify anything. Okay, then we have some issue. Okay, we have used sep equal comma. Okay, so this is very important. Then we have specified comma. Okay, so this is first issue. Okay, so x2. Okay, you see the difference. So this one is header. Okay, and so this indicate read.table header is false. So we have to specify header equal truth. Then this should be equivalent. Okay, so head x, head x2. Okay, again, we claim read.table is equivalent to read.csv. When we apply read.table to CSV file, we have to specify separate its comma and header equals true. And so this is I call inconsistency. Okay, for the read.csv function, the default value header equals true. However, for read.table, the default value for header is false. Okay, how can we find? Okay, type help read.csv, help read.csv. Then we can, you see the read.table header is false. However, read.csv header is true.
So this is I call it inconsistency between these two R function to read a text file. The last topic is to retrieve the Pico dataset from using R, and the opposite, and retrieve our dataset using Python. Okay, the first one is suppose and for my chapter, okay, type .c.all. Okay, and so this is related to the, so this part is R, the second part is Python. So let's look at .c13. Okay, so this is read R and read Pico Python dataset. Okay, we use up arrow key, we enter number 5. Okay, so this is so let's just call it paste. So this is library, and we import pandas. Okay, eventually I'm going to show. Now we are quite familiar, or my students are quite familiar, how to retrieve a Pico dataset. Okay, so we copy and paste. Okay, so this is we upload a library called rectangularate. Okay, so input pandas. Okay, so in file this is location, and so this is pd dot read underscore Pico. Okay, so let's look at the top. Okay, one issue is the date. So this is not appropriate date. And so this is, I use this part to correct the date variable. Okay, so let's copy and run it. Okay, so this one is equivalent to 1926, July 1st, 1926, August 1st, continue this way. Okay. Then we put them together. So let's call it x2. So this is x2. So eventually we got our final result. Okay. So we start from in file. We start from a Pico dataset. So eventually we end up with a R dataset. Okay. So this is from R. We retrieve a Pico dataset. Okay, the date part is a little bit tricky. Okay, C13 number 5. Okay, so these are all standard, and only the date part a little bit tricky. So our objective is generate a true date variable, here. Okay. Next, we are going to retrieve our dataset from Python. Okay, so let's find, let's search web, FF3 monthly. Okay, F3 monthly. Okay, just so we get this R dataset. Okay, we are going to retrieve using Python. Okay, so let's go back to the spider. So this is our in file. Okay, so this is our in file equal. So let's make it bigger. Okay, so we are going to retrieve so-called input is Python read R as pyr. So Python read R as pyr in file. So data frame equals pyr read. Okay, so there's a function called R. Okay, read R in file. Okay, so this is quite simple. Okay, so Python read R, read R as pyr, or simple as R, and in file data frame equals, so let's run one after another. Okay, if you don't have it, then you have to use you have to install pyreadr. Okay, so this is in file. So this is, so let's read it. Okay. File does not exist. Okay, so let's try it. File. So in file, x equal read get load URL in file. Yeah, we do have it. Okay. Oh, I know we should download it. Okay, so this is from download, import, download. Okay, and so this is out file equals ff3 rdata. So this is download in file out file. Okay, so my understanding is, so this cannot read remote one. Okay. Okay, so we have, so I'm going to run this one, and we have out file, and we download it. Okay, we download it. Okay, then we are going to read. So this is out file. Okay, so this is out file. Then we read it. Okay, then df head. Okay, so this is, so usually I use input pandas spd. Okay, and so I use x data frame equal panda data frame x. Okay, so I'm going to import pandas as panda. I'm going to retrieve it. Then I'm going to generate a data frame. Okay. I'll have to, so this is x. Okay, I think I have to do this way. Okay, so this is x. Okay, finally data frame head. Oh, okay, I know I have to use dot x. Okay, so this is because so this is x, so this is x dot x. Okay. Okay, so finally we have data frame. Okay, I just mentioned here very quickly. So basic idea is we cannot use pyreadr to read a remote dataset. Okay, we have download first. Okay, so after download it, okay, suppose we call it x, then x, and because this is inside x, so x dot x. Okay, and so this is default. Okay, so actually I'm going to show you why this is dot x. Okay, so let's go back to here. Okay, suppose a equals load URL. So this is in file. Okay, so if we use a equal load URL in file, so this is in file. Okay, so actually is dot x. So this is why we have a dot x here. Okay. Okay, so this is end of the presentation, the model.
For the R, we discuss read.csv. So actually we can find many functions related to the retrieved data sets. Okay, so actually we can use a Preface function. Okay, read. Okay, then we can search. So this is read CSV, read the CSV2, read the delimited. Okay, read Fortune. This is a fixed width file. Okay, so this is read binary. Okay, and so this is read RDS and read clipboard. Okay, so actually for the Python, for the pandas, we have the read clipboard as well. Okay, for the Python, we can look at the function starting with read underscore, included or embedded in the pandas module. Okay, so import pandas as pd, print dir pd. Okay, then we will see all the embedded function. Okay, so if we look at the function style from read clipboard, read CSV, read Excel, and you see we have so many functions we can retrieve data in different formats.